Alexander Fleming, discoverer of the first antibiotic, or the world's first BioArtist? You've probably heard about Fleming's famous discovery of the antibiotic penicillin, but you likely haven't heard much about Fleming's interest outside of science. He was also an artist and member of the London's Chelsea Arts Club. Fleming revolutionized art by taking a new approach. Instead of painting with acrylics or watercolors, Fleming chose to paint with living bacteria. Yes, you heard that right. Unlike what most people imagine, bacteria come in amazing varieties of colors. What's so interesting about Fleming's bacterial art is that his pieces weren't static. The bacteria grew right on his canvas. Well, petri dish, after he put them in place. So his works were constantly transforming. For just a few days, the bacteria would form the picture he'd intended, but this image wouldn't last forever. Eventually, the sharp lines that had defined shapes would blur as the bacteria grew out of control. Fleming's bacterial art continues to challenge our definition of what can and can't be seen as beautiful. And he's not alone. Let's check out Dr. Mehmet Berkman and Maria Penil-Cobo's bacterial paintings. But before we begin, I have to ask, are you afraid of microbes? Does dirt make you squirm? Do you think bugs are only out to destroy you? Dr. Berkman and his team believe that our collective distrust of microbes is caused by our limited knowledge of them. When do we ever hear about all the good microbes do for us? Even as we speak, there are more than 10,000 species of microbes living in or on our bodies, but they're invisible from our perspective. To make matters worse, the bugs we do see are in moldy food or in news headlines as causes of disease. Our one-sided view of microbes sadly prevents us from appreciating how much microbes benefit our world. Here's where Dr. Berkman and Penil come into play. By creating beautiful works of art from bacteria, these two bioartists hope to revolutionize the way we see bacteria and bring the mysteries of microbes to light. Let's take a look. This time-lapse video is a uniquely living work of art. We can see the bacteria grow over time to create a dynamic, constantly changing landscape that mimics a flowering plant. The creative duo has even expanded from using a single petri dish to multiple. This mask was carefully created to not only fit together like a jigsaw puzzle, but to have symmetric patterns and colors as well. This last example, titled Sustenance, is made from Penil and her baby's own bacteria. Bacteria in breast milk build up a baby's microbiome, strengthen their immunity, and improve digestion. This piece reminds us that not all bacteria are out to get us. Without some bacteria, we'd struggle to survive. Over the past decade, the bioart community has exploded. Let's check out Zachary Kopfer's work with bacteriography. It's the process Kopfer uses to print photos of famous people and places inside petri dishes of living bacteria. Wondering how it works? First, Kopfer turns a digital photo into a halftone, which is an image made out of black and white dots. He then edits the image and places it in front of a petri dish covered in red Serratia bacteria. When the petri dish is exposed to radiation, bacteria behind the white dots die because radiation makes it through. Only the bacteria behind the dark dots survive because radiation is blocked. These bacteria grow into a pattern that makes the original photo on the petri dish. Kopfer then freezes the petri dish to kill the remaining bacteria and covers it in layers of acrylic to preserve the photo. These even brought the night sky to life with genetically modified bacteria that glow in the dark. But bacteria aren't the only microbes used by bioartists across the globe. Jasmine Temple is famous for yeast art. While the white yeast in bread might seem boring, these vibrant pictures are made from genetically engineered yeast that span all colors of the rainbow. Believe it or not, but using a coloring book is quite similar to Temple's yeast art process. Temple uses a digital image and then breaks it down into pixels, which are like tiny squares in a coloring book. She then uses an algorithm to determine which color of yeast best matches each pixel in the image. Sounds a lot like the map of 1s, 2s, and 3s used to match squares to colors in color by number books. But instead of using colored pencils, Temple uses a machine called the LabSite Echo 550. It uses sound waves to eject tiny droplets of yeast into smart wells on an agar plate. After 2 hours of printing, the agar plate looks completely clear. It's only after 3 to 4 days of growing that the colorful yeast are seen. The agar plate is then transferred to a cold room where the colors intensify. This piece, titled New York City Sunset, is made of 24,576 pixels, but it's only the size of a postcard. Temple also created a stop-motion animation using the same process. Titled God and Eve, this animation shows two hands slowly coming together. or God and Eve first making contact. But it could also represent humans and microbes, the moment we're arriving at right now, as our curiosity about microbes overwhelms our fear of them and entices us to learn more. From paintings and photos made from bacteria to animations made from yeast, it's clear that science, like art, can be beautiful and creative. Maybe, just maybe, art and science aren't as different as we think. Thanks for watching!